Okay, let us recap of yesterday's class a little bit. So yesterday we have discussed about this operators concept. Okay, so here, so the definition of operator is it is a symbol which specifies certain operation or activity. So if you look at the symbols on the keyboard, so for some symbols we can call it as operators because it performs some activity, or we can say operation, and we can expect result out of that operation. Okay, so operators are mainly applied on variables and constants. So we know the concept of variables and constants. So in an expression or in a given equation, so according to mathematics, so we come across variables as well as constants. Okay, on those things operators can be applied, and those things are called as operands. So operators operate on constants or variables which are called as operands. So whenever we look at the equation, so we come across two things. One is operators, another one is operands. Okay, so if we take out the operators, remaining thing is operands. That means either constants or variables. So for example, if you look at this, c equals to a plus b. So here plus and equals to signs or operators, whereas a, b and c are operands. Okay. So it is very easy. So you have to take out the operators first. So plus and equal to. So remaining things a, b and c are operands. So those are the variables. So if you look at the next equation, c equals to a plus 10. Okay. So here also plus and equal to are the operators, whereas a, c and 10 are the operands. So in these operands, again, a and c are variables, 10 is a constant. So in a given equation or an expression, so it may contain all variables or all constants, or some of the variables and some of the constants. Okay. Next, classification of operators. So arithmetic operators: relational, logical, assignment, conditional, shorthand, bitwise. So these are the classification of operators. So if we go to the arithmetic operators, so from mathematics we know it's very easy. So to perform operations such as addition, subtraction, multiplication, and division, so we use these operators, that is arithmetic operators. So in the table it is mentioned. So for addition we use this symbol called plus. So example is 5 plus 2 equals to 7. So subtraction, minus 5 minus 2 equals to 3. Multiplication, so actually in mathematics we use this symbol, that is x. Okay, that is into mark. But in computer language, so star is used for multiplication. That is called asterisk. Technical term is asterisk, or we can call it a star symbol. So 5 into 2 equals to 10. Next comes the division symbol. So this division symbol is nothing but forward slash. So depending on the so depending on the requirement, so this symbol we have to use. Okay. So here, so when we come across the division symbol and this percentage symbol, that is division and mod symbol, it's called as mod symbol. So a little bit something we have to learn here. So that is, when you apply this division and mod symbol, for both the things operation is to divide only. Okay, that is 5 divided by 2, and here if we call 5 mod 2, the operation is division only. But what happens, so when we use the symbol that is forward slash, that is division symbol, So quotient will be the answer. So when we use the symbol percent symbol, that is mod symbol, remainder will be the answer. And you should not divide further. That is, you should not say 2.4, 2.5. In mathematics, it is correct. But in programming language, if the numerator and denominator are integers, so you have to stop at the integer part answer only. So don't divide it further. And remaining thing is remainder. Okay. So 5 divided by 2, 2 into 2, 4. So 2 is the quotient. 2 into 2, 4, remainder is 1. So that will be the answer for percent symbol. So division of one integer uh, number by another integer number is called as integer division. So this operation always results in integer value. The fractional part of the quotient is truncated. So the fractional part is truncated. So if you look at this example, 5 divided by 2 equals to 2 is an integer division. Then, so when you apply the mod symbol, you should be very careful that you should apply only to integer numbers, not for the floating point numbers. Okay. So we cannot say 5.2 divided by 2.5 like that, or even 5.2 divided by 2. Numerator and denominator both should be integers. Then only we can expect the result from. Okay. So then only we can expect the result from mod symbol, uh, that is 1. Okay. So once again we will look at this arithmetic operators. Sir is requesting. So in arithmetic operators we have the symbols plus, minus, star, that is asterisk technical term, division symbol, that is forward slash symbol, then the percent symbol, that is mod symbol. Okay. So plus is used to add, minus is used to subtract, asterisk, that is star, is used to multiply. So whereas in mathematics we use the uh, this symbol, that is x, or we can call it as into mark. But in programming language, computer language, we use star symbol, uh, for which it does multiplication. Then comes the division symbol, then comes the mod symbol. For the last two operators, remember operation is division only. Okay, that is 5 divided by 2. Again, for the last row, it is 5 divided by 2 only. Only thing is answer matters. So in case of division symbol, the answer will be 2. That is only quotient. In case of mod symbol, the answer will be 1. That is remainder. You take any numbers, not only this example, you take any numbers. So if you divide numerator by denominator with the division symbol, answer quotient will be the 2. And for mod, it is reminder, that is 1. If we divide for floating point numbers, then you can expect the answer what you expect in mathematics. But if you take only integers, that is integer number divided by integer number, will get the answer in integer always in case of programming language, that is especially in C language. And in case of percent symbol, so we'll get the remainder as the answer. So when you use this percent symbol, you should be very careful that numerator, that is 5, and denominator, that is 2, both should be integers. You should not use floating point numbers. Whereas in case of division symbol, you can use either numerator or denominator as a floating point number, or both as floating point number. It's not a problem. You can use both as integers, one as floating point number and another as integers, or both as floating point numbers. But when you go for the mod symbol, both should be integers. That is the rule. So here explanation they have given. Division of one integer number by another integer number is called integer division. So this operation always results in integer value. If you look at this example, 5 divided by 2, we'll expect the answer always, that is integer. We'll not expect floating point value here because both are integers here. The fractional part of the quotient is truncated. So actually answer will be 2.5, but this fractional part, that is 0.5, will be truncated. So answer will be only 2. So example 5 divided by 2 is an integer division. Then when it comes to mod symbol, that is percent symbol, it is used for integer values and not for floating point numbers. So if you apply floating point numbers for mod symbol, you will get an error in a program. This operator returns remainder after division. So while doing operation, you can say divide 5 by 2. While writing the symbol, you write percent symbol. So when you read out, you read 5 divided by 2. Okay, divide 5 by 2, and the remainder is 1 here. Okay, that is 2 into 2, 4. Remainder will be 1. Okay, next. So coming to the relational operators. The relational operators are used to compare two operands. So here operand meaning either two variables or two constants, or one variable and another constant. So because operand meaning variable or a constant. So both can be variables, both can be constants, or one variable or one constant. So it is used to compare two operands. So it results in either true or false. Okay. Uh, so only two results here, true or false. True means 1, false means 0. Or you can consider true means yes, the answer is yes, false means the answer is no. Okay. Now if you look at this example, so 5 less than 2, just you read like English only, is 5 less than 2. See, when we solve these relational operators and logical operators, so be careful. So just make it slow. Even if it is, if it takes time, don't worry, just make it slow. Is 5 less than 2? If I ask the question like this, is 5 less than 2? Answer will be either yes or no. Okay. If the answer is yes, then it is true. If the answer is no, then it indicates false. So if I ask the question, is 5 less than 2? Is 5 less than 2? Answer is no. So no means it is false. Is 5 greater than 2? Answer is yes. That means true. Next, is 5 less than or equals to 2? So is 5 less than or equals to 2? So here we come across two questions. So yesterday we have discussed it. That is, see, if I say, so if I consider 5 less than or equals to 2, okay. So in this, while reading, if I read it, you will understand. Is 5 less than or equals to 2? That means I'm using the word or. So whenever we use the word or and, so two words are there. If I use or one more word and, that means before the word or some sentence will be there, after the word or some sentence. Similarly, before the word and some sentence will be there, after the word and some part of the sentence will be there. So in this example, if I read like is 5 less than or equals to 2, so how we can read is 5 see less than 2. So this is one question. This will act like one question. Another is 5 equals to 2. Okay, that means two comparisons we are doing. First comparison is 5 less than 2, second comparison is 5 equals to 2. So while reading, what we read is 5 less than or equals to 2. So if I say is 5 less than 2, what is the answer? Is 5 less than 2? No. Okay, then is 5 equals to 2? No. So that means both are, for both the things we are getting the answer as no. So final result will be no here in this case. That means if I say final result is no, that indicates it is false. So if you observe in the table, is 5 less than or equals to 2? Answer is false. That is the final result. So by considering the questions, is 5 less than 2? No, false. Is 5 equals to 2? No. So in both the cases it is no. So final answer is false. But if we go to the another example in the table, is 5 greater than or equals to 2? See, while reading, see, if I say is 5 greater than or equals to 2, so what we say? Yes, because 5 is greater than 2. If I break this into two questions, if I say is 5 greater than 2, one question, then is 5 equals to 2, second question. Now it will be confusion for us, because is 5 greater than 2? Yes. Is 5 equals to 2? No. See, we are getting one answer as yes, another answer as no. So for yes, we can consider it as true. For no, we can consider it as false. In this case, what will be the final result? Because in one case it is true, in another case it is false. So for these type of things, for this type of constants, we have to go to the another category of operators, that is logical operators. So here we can write directly it is true, because I have written in the table is 5 greater than 2. Yes, it is true. But how it is true, we will get the answer in the logical operators. So next set of operators is logical operators. So according to mathematics also, in mathematics, if we come across this question also, we will say true only. Is 5 greater than or equals to 2? Yes, it is true. But there we don't have logical operators, but here we have the concept of logical operators. There we will say it will be very clear for you. Next, is 5 equals to 2? No, directly we can say it is not equals to, it is false. Is 5 not equals to 2? Yes, it is not equal. Both are not equal, so it is true. Okay, next we will go for the logical operators. I think yesterday till here, if people have understood, if you have any doubts, you can ask now. Till yesterday's class. Now we will move further. Okay. So coming to the logical operators, uh, logical operators are used to combine two or more relational expressions. So here the meaning of expressions is equations. So as I said, from mathematics we got this term, that is equation. So in mathematics we call it as equation. In programming language we can call it as expression. So logical operators are used to combine two or more relational expressions. So then what is relational expression? We get a question. So it's very easy. So whatever the examples we used in this table, these are all relational expressions. That means equation. Expression is nothing but equation, where it contains relational operators. So what are the relational operators? Less than, greater than, less than or equals to, greater than or equals to, and not equals to. These are the relational operators. So in a equation, if you come across any of these operators, then we can call it as a relational expression or relational equation. Now when we go to the arithmetic operators, in a equation or expression, if you come across these symbols plus, minus, star, division and mod, then we can call it as arithmetic equation or arithmetic expression. So arithmetic expression, relational expression and logical expression. So I hope you know what is relational expression now, because in expression if you come across these type of operators, then we can call it as relational expression. Then coming to the logical expression, so if we want to frame an logical expression, then minimum two relational expressions it should contain. Okay, two or more, okay. So now then the result, we have to think about result. The result of logical expression is either true or false. Then comes the question, why it is true or false? Because logical expressions result is true or false. So sorry, relational expressions result is true or false, therefore logical expression result is also true or false. If you look at this table, above table, all these are relational expressions. So for all these examples we are getting results either true or false, none other than that. Similarly for logical expression also, result will be true or false. Okay. So now we'll see what are the logical operators. So basic definition again, I will say once again, logical operators are used to combine two or more relational expressions. Expressions are nothing but equations. So relational expression means where it contains relational operators. So there are six relational operators: less than, greater than, less than or equals to, greater than or equals to, equals to. And while calling this operator particularly, don't call double equal to or equal to. Some students will be calling like that, so I'm said just you call equals to. Is 5 equals to 2 enough? No need of calling is 5 equal to 2 or is 5 double equals to 2. If we simply say is 5 equals to 2, it is understood. Because if we use single equals to, I will tell you why we should not call like that. If we use single equals to, for this one category of operator is there. Next it will come assign, it is called assignment operator. So if we use single equals to, it is called assignment operator. If we use double equals to, it is called relational operator. So there is a difference, so no need of worrying here. So directly we can call is 5 equals to 2. It is understood that it is a relational operator. Okay. So if you want to mention to the receiver end that we have used double equals to, then it is understood. Okay. Next, coming to the types of logical operators, so we have logical and, logical or, logical not. Okay. So logical and operator, we have to use ampersand symbol. So in character set we have discussed, that is all the symbols on the keyboard, technical terms we have discussed. So if you use two ampersand, so just I will mention here because we have discussed in the previous classes. So ampersand symbol it is, or it is also called as address symbol. So by two terms it is called ampersand or address symbol. So if we use two ampersand symbols continuously without space, so if we use space, again the meaning is changed. So if you use continuously without a blank space, then it is called as ampersand symbol. See, if we leave this space in between, individual symbols are called as address symbol. Or there is one more category of operator, it is called bitwise operator. So whenever we use logical operators, we should be very careful. So you should not leave a single space also. Okay. So continuously we have tried. Then it is called as logical and operator. Symbol name is ampersand or address symbol, but when you combine it and use in an equation, it is called as logical and operator. Okay. Then coming to the logical or. So this symbol, in the keyboard, there is a symbol called as pipeline. Okay. That is actually, while writing, how we write is, in this vertical line in between there will be some gap. Okay, that is called logical or on some keyboards there will be no gap. I think you have to just observe in your keyboard list. Okay. that symbol is present, you have to press shift key and you have to type that key. Okay, by pressing shift key you have to type backward slash symbol. So on my keyboard, on the so on the so on the keyboard, see here on my keyboard, for backward slash there is this pipeline symbol. So if I press without shift key it will print backslash. If I press with shift key it will print pipeline symbol. So if we type continuously two pipeline symbol, then it becomes logical or. So you should not leave blank space in between. Okay, then coming to the logical not. So this is exclamation mark of English language. Okay, so it is present on the keyboard. Okay, so we will see in detail of these things. So first one, logical and operator. So the result of logical and operator is true only when the results of all conditions are true. See, one more thing what we have to call for expressions, especially for relational expression and logical expression, is we have to call this as like a condition in technical terms. In programming language we have to call this as a condition, because where it results in true or false. Okay, so where it results in true or false we can call that as a condition. So here, is 5 greater than 2, is 5 less than 2, it will result in yes or no answers. So where it results in yes or no answers, so we have to call that as a condition. Okay, so now in this explanation what they are telling, the result of a logical and operator is true when the results of all conditions are true. That means more than one condition we are using, that is nothing but more than one expression we are using, more than one relational expressions. The basic definition of logical operators itself, it says logical operators are used to combine two or more relational expressions. Relational expressions are nothing but conditions only. Whenever we use relational expressions, that is relational equations, those are nothing but conditions only. We can call it as relational expressions or conditions. Okay, so if we are using two or more relational expressions, that is conditions, when all the results of those conditions or expressions is true, then only the final result of logical and operator will be true. If any one condition is false, then the total result will be false. So they have derived this table, that is truth table. Okay, so that is, see, condition 1 and condition 2. So for condition you can consider one, you can consider expression, even expression 1 and expression 2, or operand 1 or operand 2, because the meaning of operand is variable or a constant or an equation. So again I will tell, the meaning of operand is variable or a constant or an equation, that is expression. So here that expression we can consider it as condition. So if you look at this truth table, so they have given two conditions. So it can exist more than two conditions also, it is exist minimum requirement. This is, so condition 1 you have to take, condition 2 you have to take. Then from true and false you write four possibilities. Okay, that is, if you consider both are true, if you consider one is true and another one is false, so first condition is true, second condition is false. If you consider first condition is false, second condition is true, if you consider both the conditions are false, then what will be the result? Okay, by looking at the definition we can understand. So what is the definition? The result of a logical and operator is true only when the results of all the conditions are true. Here all the conditions means how many conditions are there here? Only two conditions. So you just look at all the rows and you look at where both the conditions are true. Only in the first row both the conditions are true. So condition 1 is true, condition 2 is true. Okay, then only in the first case you have to write result to true, in the remaining cases it is false only. Okay, that is the rule of logical and operator. Okay, only in the first case it is true because all the conditions are true. All the conditions means here two conditions are there, that is more than one condition. So if two conditions exist and if the two conditions results are true, then the final result will be true. In the remaining cases it is false. Okay, 1 minute to wait. Okay, see here just I have taken one real world example, means as per my knowledge, or uh, for you people to understand it. See, we will get one question here, that is, see, once we write this truth table, we get a question whether we have to by heart it or how to remember. Okay, so you can remember this logically by thinking logically. So you just look at this example. So just you consider this as an example. Maybe rules will be very much different from this. Just I am considering this. So for example, if we consider to join the military, so Indian military or any country military, that is any one we will take Indian Navy or Air Force or Army, anything. So if you consider IAF, Indian Air Force, just we will consider this example, just assumptions. So if a person want to join the army, that is Indian Air Force, if they keep the rules, that means if they keep the conditions like he or she should be of height 6 inches, no sorry 6 feet, okay, just I have mentioned here, and weight 60 kg. So if both are okay, then only you can join. If that is the rule, you just write the possibilities. Okay, see, in the first case, height 6 feet, yes. Weight 60 kg, yes. So both are correct. So if both are correct, that means if both the conditions matches, then he can join the army. If that is the rule, then in the remaining cases everything is false, because if one thing fails, that is if height is 6 feet and if the weight is not 60 kg, then also you cannot join. If weight is 60 kg but if the height is not 6 feet, then also you cannot join. If if uh, if he or she fails in both the things, that is height and weight, then he cannot join. See, from this example we can understand how the truth table they have framed. Okay, when we use the word and in English also, when we use the word and, before the and whatever the part of sentence is there, after the word and whatever the part of sentence is there, both should satisfy, then only the complete sentence will become true. Okay, in case of or, word or, either this or that, by the sentence only we can understand either this or that. So that will explain further. I hope you people have understood this logical and operator. Then we will go for logical or operator. Okay. Hmm. See, in case of logical or, what happens? The result of a logical or operator is true when any one of the condition is true. Okay, that means given n number of conditions, that is more than one conditions. So if any one condition is true, if any one condition is satisfied, then the result will be true. The result will be false only when all the conditions are false. Okay, so it is we can think it is opposite of and. In case of and, result will be true only when all the conditions are true. Here in this case, result will be false only when all the conditions are false. If you look at this truth table, so write the possibilities, true and false. Write the possibilities. Four possibilities we can write. Both true, one is true, another one is false. First condition is false, second condition is true, both are false. These are the four possibilities what we can write. When you go to the result part, so you just remember the false category, then it's very easy to write true category. So when we can write false, when all the conditions are false, that is last row. So if you remember this, remaining things are all true. In case of logical and, remember the first thing, that means when all the conditions are true, then the result is true. So remaining thing it is false. In case of logical and, remember the first row, writing all the rows will be very easy. In the case of logical or, remember the last row, writing all the other above three rows will be very easy. So for this also we consider the see, again same military example. If you consider, you will understand better what I'm saying. You just go to the second part, or part. So in case of what, if they tell the rule that if either height should be 6 feet or the weight should be 60 kg, then he can join the army. Then you look at these possibilities. In the first case, if he or she is of height 6 feet and weight is 60 kg, yes, he can join. Or if he is of height 6 feet but weight is less than 60 kg, then we cannot say cannot join, because they are telling either this or that. If height is 6 feet, if the weight doesn't match, yes, he can join. If the height doesn't match but if weight is 60 kg, then he can join. So just I'm giving example. Should not compare this example with military. Just I'm giving example. If both are failing, that is if the height is less than 6 feet and if the weight is less than 60 kg, then he cannot join. So if one condition satisfies, then he can join. In case of or, in case of and, both the conditions should satisfy, then only he can join the army. Yes meaning true here, that's all. Okay, next we'll go for logical and. the result of logical not operator is true when the condition, that is input, is true. The result will be false when the input is true. So that is, it is opposite. If the condition is true, result is false, that is output. If the condition is false, result is true. Okay, it's very easy. uh, Condition means here input, or we can consider operand. If the condition is true, the result is false. If the condition is false, the result is true. That is opposite of the input. That's our output will be the opposite of the input. Result will be the opposite of the condition. Now you can write it. So if you have any doubts, you can ask. I think yesterday you copied till relational operators. Now you can copy with logical operators.
Pradeep?
Ah, yes, sir.
Yeah, sorry, I thought I'm missing. Okay, I mean, I got the first two very clear, logical and
Ah,
relational, operator. The
okay.
third one is something little bit, the logical not is something that puzzled me in terms of, because you say if it's true, then the output is false. So
Ah,
can you just explain that once again, please?
okay, sir. We'll do it. Let all
Yeah,
copy
once,
this thing.
yeah, sure. No problem, no problem. I can wait.
But how about logical and or, sir? Is that fine?
Yeah, that is clear. That is clear.
Fine. Fine. So completed writing. Okay. So there is a table for logical not before